Ben here?
Yes.
Where's Ben? There's Ben. So here we go. 1 second. Wait.
You know how everyone's suddenly obsessed with AGI? Yeah, he named that. Dr. Ben Goertzel coined the term before it was a buzzword, before it was a boardroom panic, before Elon had an opinion about it. He's written 25 books, founded SingularityNET, the world's first decentralized AI network. And right now, he's running the largest AGI project on the planet outside of big tech. Not for profit, for all of us. That's either visionary or audacious. Honestly, it's both. Please welcome to the stage, Dr. Ben Goertzel.
Hey, thanks. Thanks, everyone. And yeah, it's a pleasure to be here. So I've given a bunch of talks on AGI over the last years and decades, but I have to say this kind of community is really among my favorite to talk to, because I mean everyone gets already like why AGI should be open and decentralized for the good of everyone. Like we don't have to argue that point. So I can get into some of the more interesting stuff, right? And we saw on the screen a few moments ago Elon Musk saying we're going to get to AGI in 2026. The singularity is here already, right? And I mean, I get the vibe and the spirit of it, and on a historical time scale, it's kind of right. Like, I mean, our species has been civilized for 10,000 years, if we want to call ourselves that. But I mean, we've had computers for how long? 75 years or something. So I mean, on the overall time scale of our history, yes, we may be essentially at the moment of the singularity, but yet the difference between where we are now and actually having human level AGI, while brief in the historical timescale, it's a very important gap. And it's important because we can do stuff in that gap to try to make the AGI come out better, such as making it open and decentralized and for the good of everyone, right? So I mean, on the whole, I'm an AGI optimist, both in terms of timing and in terms of the ability and potential to make AGI come out in a broadly beneficial way. But I don't think beneficial AGI is automatic or inevitable, and I think we sort of have to do stuff right to make it come about, right? And I've been thinking about this stuff, probably like many others in this room, for a long time before it became popular, right? Like, and I think first was seeing a robot in the original Star Trek in like 1970 or something, right? And it was a robot that was roaming around in deep space, and it had some sort of bug in its hardware. It was supposed to be fixing stuff. It was annihilating things instead. And I remember Spock and Kirk managed to somehow psych it into a logical error. And it was spinning around going like error, 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 error. And I remember must have been like 3 or 4 years old. I was like, this doesn't make sense. If this robot is smart enough to, fly around multiple galaxies and annihilate civilizations, shouldn't it be able to deal with a simple logical paradox somehow, right? But it was interesting. And then a few years after that, 73 or 74, I read a book called The Prometheus Project by a Princeton physicist named Gerald Feinberg. And what he said is, in the next few decades, we're going to get machines that can think smarter than people. We're going to be able to build machines so small we can't see them. And we're going to prolong human life indefinitely. And the challenge will be, do we use this for consciousness expansion or for mindless idiotic consumerism, and who makes the choice? And he proposed that the UN send computerized voting equipment to every person in the world to decide whether, like, immortality, AGI, and nanotech should be used for intelligent and wonderful or stupid goals, right? And obviously that didn't happen, and I never met that guy. He died in the 1980s. But these ideas were out there already, right? Both the potential that technology can lead to, the potential for it to be used for good or less good, and the value of participatory democratic decision making about the outcome. Like, all these ideas were there in a book published in '68 that I found in like a Haddonfield, New Jersey used bookstore in '73 when I was a little kid, right? But now obviously all this is big time and getting real, and national leaders have heard about all this stuff, and there's tremendous amounts of money being orchestrated by people like Elon Musk, Sam Altman, or Xi Jinping for that matter, like people who take these ideas seriously, right? So while the core notions are not new, and even the core tech ideas are not that new, like deep neural nets existed already when I was a little kid as well, with multi-layer perceptrons and whatnot. I mean, the real stuff that's happening now is new, which is what is bringing everything to a head, right? And yeah, 2005, I published an edited volume of academic papers on AI design called Artificial General Intelligence, and started organizing an AGI conference series each year. By the way, the next one is at San Francisco State University in late July. So if you look at agiconference.org, it'd be great to have some of you folks there. But that put the name AGI out on the map. I later found out a guy named Mark Guberud had used the term in an essay on nanotech in '97. So I wasn't actually the first one to use the term, but I did. I put it out there in a book that a few people read, and in a conference that people went to. And in that same year, 2005, Ray Kurzweil published his book, The Singularity is Near. He now has an updated version, The Singularity is Nearer. So maybe him and Elon can co-author The Singularity is Here, right? Or The Singularity came and you missed it while you were sleeping. Right? But in The Singularity is Near, Ray Kurzweil proposed that 2029 will be the year that we had a breakthrough to human level AGI. And he then said 2045 for essentially superintelligence, right? Like a laptop being as smart as the whole human species, as he put it. It's interesting. So now 2029, I think, looks like a foresighted guess as to when human level AGI will come about. I mean, Elon and Dario think it may come a little sooner. I mean, folks say it'll come a little later, but it's more of a plausible idea to more people than 2005. But the gap between human level AGI 2029 and superintelligence in 2045, I think now seems way too long to quite a lot of observers, right? Because if you look now at even what LLMs can do in terms of proving math theorems and helping do science, it's and helping code, right? Like, it seems like if you really get a human level AGI that's mind melded with Claude code and whatnot, that thing is going to be able to upgrade its own software infrastructure. It's going to be able to design new hardware for itself. Like, it's hard to see why it would take 16 years from human level AGI on to superintelligence, unless there's World War III, or the superintelligence, but the AGI wants to slow down its own development, right? So I think we're now at a very interesting point where the near-term advent of AGI seems like a plausible thing to very many people, and it's a question of how do we do it and how do we do it right. So I'm gonna, having used half my time on the opening slide, I'm now gonna zip through the rest of my slide deck and try to explain. Oh yeah, I think I like this mic. I enjoy waving it around. Yeah, yeah. Clicker. Yep, I got it. So yeah, let me try to briefly race through how I think AGI can be created in a beneficial, decentralized, and open way. And I mean, I do think it's not just rhetoric. I think this actually is the most important thing in the history of our species, right? I mean, we've had very dangerous things before, like nuclear weapons, and we've certainly had, you know, life-changing inventions like print media and the internet and the wheel and the internal combustion engine. But I mean, these have all been invented by human brains, right? And getting something that's smarter than human brains, I mean, this, and more practically capable than humans, like this is it, right? Like this is the biggest thing in our history. And right now is the moment when we can make a critical impact here, right? Because I mean, the technology is getting there. Regulatory environment is chaotic and confused, and we're at a time where there may be a significant first mover advantage. Like, if, for those of us who are into open and decentralized stuff, if the first AGI popped up in an open and decentralized way, it's not that there won't be closed AGIs copying it, but you know, it took Google 3 years to catch up with OpenAI on LLMs, even though Google invented transformers, right? So first mover advantage is a thing. Now, I think there should be many, many different approaches to AGI pursued, and there may be many that succeed. There may be many kinds of artificial minds, just like there can be many kinds of biological minds. That said, I have some particular ideas about how we're most likely to get to AGI. And I think I sort of sympathize with Jan LeCun, who said that on the highway to AGI, LLMs are an off-ramp. But I think it's a half truth, because I think you can't get to AGI by scaling up LLMs. It's not going to do it. They can't go far enough out of their training distribution, in my view. On the other hand, in the bigger picture, like, they're astoundingly valuable tools to use to create other things that incorporate LLMs along with other methods. And I'm working on a framework called Hyperon that brings deep neural nets together with logical theorem provers, together with evolutionary learning and other methods, in a sort of common in-RAM self-organizing hypergraph. I'm very optimistic about this. I don't think it's the only route to get to AGI, though, and I think there should be a lot of different approaches pursued at once, which is what we talk about at the AGI conference. In our Hyperon system, which I would love to recruit more people to start playing with, but by the way, the core data structure is a typed weighted in-RAM metagraph. So it's like a big, very flexible knowledge graph, can live in RAM, can coordinate, decentralize, and distribute across multiple machines. There's a unique programming language called Meta, M-E-T-T-A, which is a sort of functional logical language. Each program is a subgraph of the metagraph. Each program acts by rewriting metagraph into more metagraph. And as of like 3 months ago, it works very fast, which was years of work, but it's cool. Like, we have a fast compiler for this weird functional logical probabilistic language. We have a very fast, fully open source knowledge graph. I mean, it's faster, more flexible than Neo4j and the proprietary things. We've got a lot of nice infrastructure, which we spent multiple years cooking and now basically works. And we have a cognitive architecture called Primus, because Elon had Optimus. And if you know the original cartoon Transformers, like, Primus is above Optimus, right? He could transform into a whole planet, not just a truck. Right? So we have cognitive architecture called Primus that tries to explain how all the different kinds of learning and reasoning in the human mind can be done in this sort of self-optimizing metagraph framework. And the whole cognitive architecture is more than I'm going to try to outline in the next 5 minutes or so. But I mean, it involves deep neural nets, but it also involves explicit probabilistic logical reasoning, where you can propagate higher order distributions through higher order predicate logic, theorem proving, and so on. It uses sort of genetic programming. You can evolve whole programs living in the metagraph. You have an explicit motivational system. So it's not just trying to optimize one reward. You can have multiple different goals, and the system can create its own goal as well as pursuing the ones you gave it. and not everything is goal-directed. I mean, I think being goal-directed is important, but for none of us is everything goal-directed, right? Like there's ambient, self-organizing cognitive dynamics going on, and I've written a bunch about all this, like over decades and recently. The cognitive architecture is very, very important. I mean, it's just as important as the infrastructure, and I'm skipping it over here just because it's not the focus, not because it's not important. In terms of deep neural nets, I do think they have a big role to play. I think backpropagation is probably got to die for us to get to AGI, because backprop doesn't do continual learning. So there's a lot of other ways to train deep neural nets. None of them has been scaled up to the level of backprop. I think they will be in the next couple of years. I mean, one is predictive coding, which is a long history. Causal coding is my own invention, improvising on predictive coding. But these are purely local learning methods, right? And there's an important thing here in terms of decentralization, because with predictive coding, like each neuron does its own learning, and then the whole network self-organizes, sort of more like a Hopfield network in a way than like a backprop network. Now, actually, one of the things that incited me to come to this conference was seeing that Reza had given a talk on fluidic neural networks. Now, I wrote a paper on this last year. You can take the Bellman equation, underlying reinforcement learning, and it maps by an interesting one-to-one transformation into the Navier-Stokes equation, underlying fluid dynamics. So you can actually make an alternate kind of neural net that evolves by fluid dynamic equations, right? And there's pluses and minuses to that. That could be a whole talk or symposium or something. But the point is, as well as there being other things besides neural nets, there's other ways to train neural nets besides backpropagation. And backprop doesn't work for continual learning, right? And this is something I can't believe that big companies are not paying more attention to, this very large problem, right? This is why we have these models like, 5.2, 4.0, right? Because you train the thing, then you have to freeze it and do inference. But I mean, that's not how the brain works, and it's not how an AGI should work. And it's the limitations of backprop as a learning algorithm, not really the limitations of formal neural nets as a data structure. And it is bizarre to me that the whole AI industry is so locked into backprop as a learning algorithm. There's not huge research programs aimed at better learning algorithms. So I mean, we're within my AI research team at SingularityNET, our decentralized AI platform project. I mean, we're working on the Hyperon neural symbolic evolutionary knowledge metagraph approach. We also have a team working on predictive and causal coding as decentralized approaches, right? So, I mean, what Quai is doing with decentralizing training of backprop-based neural models is great. It can become even greater if you have a more decentralization-friendly neural infrastructure, right? And that brings me to this next point: is decentralized infrastructure is another important part of the whole thing, right? I mean, you totally want AI methods that are AGI worthy, but you want AGI worthy methods that are amenable to decentralized learning also. And then you need a whole bunch of high class plumbing to allow the decentralized learning to work. And Quai has some pieces of this which are very nice. I think in SingularityNet and ASI Alliance, we have some other pieces of this that are nice. And I think these can be combined together in various interesting ways. And seeing all this horrible mess in Iran that our great leader Trump is orchestrating now, I mean, it made me reflect on how energy wars and AGI wars intersect. And I won't divert the next 5 minutes of the talk onto this, but I would say that centralizing AGI in a few huge hyperscaler server farms pushes to centralize energy in a few locations, which makes geopolitics even nastier than it would be otherwise. And if AI were decentralized, its use of energy could be decentralized, which makes less of a nasty synergy between AGI wars and energy wars, right? So there's a lot of reasons why decentralized infrastructure is important. And I think one thing I'm hoping to see this year is to get a positive flywheel with our Hyperon proto-AGI stuff where we're using our Hyperon tools to help develop the next generation of Hyperon tools, because we do see that with LLMs now, right? Like we're all using LLMs to help code, and you can use LLMs to help code better LLMs. So if you have something smarter than LLMs, and you can use that to help improve the thing to make it even smarter than LLMs, right? I mean, then that's a sort of flywheel that could make AGI come in 2027 or whatever, right? So for the last couple of minutes here, I want to move to something less interesting but also important. So, which is, how do we structure all this from a sort of business and operational standpoint, right? Because Hyperon and my predictive coding work, these are all open source code. So that's sort of table stakes for me, and I guess for most people in this room. SingularityNET is a utility token powered entity building decentralized infrastructure, and we've been developing Hyperon and predictive coding neural nets within that framework. But I think, I mean, building AGI goes beyond a utility token project and beyond the decentralized infrastructure. So we're looking at, as a sort of sister project to SingularityNet, creating something called OpenBGI, Beneficial General Intelligence. And I've put a bit of thought here into like what went wrong with OpenAI. Now, a lot of things went right. They built awesome tech that I use all the time, as do many, although I'm using it less now after recent political developments. But I mean, they've obviously been a success. But I think if you want to do a thing where a for-profit, which has its value and importance, is paired with a nonprofit, you need to set up a little differently, and I've put some thought into that. I mean, each of the nonprofit foundation and for-profit lab need to have some money. They each need to have some people. They each need to be developing some stuff, right? And then they need a cooperation agreement between them, rather than just having the nonprofit have a sort of nominal governance role. And if you're going to work with a big company to get compute, maybe you have to, and that can be great for many reasons. You don't need to give them majority control, right? Like you can do a joint venture with a big company, get compute, build a product together, right? And you want to bring this into collaboration with sort of broad decentralized groups of ordinary people who want to weigh in on how all this thing should work. And there's something called the BGI Nexus, Beneficial General Intelligence Nexus, that we've been pulling together, which is just a decentralized network of ordinary people around the world who want to have input, like into what is the motivational system of the AGI, what is the AGI actually used for, right? So we cannot guarantee a beneficial outcome for humanity through the launch of AGI and superintelligence and so forth. We're utterly stepping into the great unknown. But I think if you do a few things non-stupidly, you can bias the odds of a beneficial outcome, right? So open source is good. Decentralized infrastructure is good. Participatory governance is good. It doesn't have to mean a vote by a committee. There's a lot of ways to do participatory governance. I mean, you want to build an AGI system that has an ethical goal system rather than just trying to serve its master or just doing random stuff with no goals or aspirations whatsoever, right? And you want to then have the system get its life started doing beneficial, useful things, like not, for example, primarily killing people or spying on them, but those will be done. But we have education, we have medicine, we have open source development, we have lots of good things. So I think if we can do these various things in this sort of obviously beneficial way, we could fulfill the essence of what Musk, Altman, Amadei, and the others are after, but in a way that isn't concentrated in a few big corporations and governments, in a way that actually helps everyone on the planet to flourish as superintelligence emerges. So I don't think we're at the singularity now. I don't think we have AGI now, although we have amazing software now. I think we could get there in a couple of years. I mean, I don't know if it's 1 year or 3 years. I don't think it's 10 years. I think if Hyperon works and predictive coding works, I mean, in the next year, we can get our stack, fully built out and scaled up, and then we're on to teaching it and integrating and so forth. And I mean, we all know the micro level uncertainties that come in building something this complicated. And we can all also see how much faster development is going now with LLM tools, right? So I do think we're potentially close to building a human level AGI, and we have the ingredients to do it in a beneficial way. But for better and worse, like there is an AGI race upon us, right? Like I think if we had a sort of rational global democratic government, you could. Yeah, I know that's the best joke I've ever told in my life. But if we had a rational, global, beneficial world government, you can imagine humanity just voting, like, let's slow down on AGI development while we kind of figure out how to make sure it's for everyone's good, and we'll accept the lack of some good things while we do things more conservatively. The world is very much not like that right now. We have an AGI race thrust upon us by US and Chinese governments, right? And it would have been Russian government too, if not the Ukraine war, right? I mean, I was with Putin in 2019. He gave a talk on AGI at the AI Journeys conference in Moscow, right? So I mean, the geopolitical realities are pushing us toward an AGI race, but it's not written that centralized companies together with governments will win the AGI race. And I think the best chance the decentralized world has of winning is if a better way to do AI happens to emerge first in the decentralized world. Like I think if we're just playing catch up with transformers in the decentralized world, it's very hard to win an AGI race, although we can still do a lot of good, right? But if a better way to do things, like the next ChatGPT, but better, like pops up in the decentralized ecosystem, then the centralized world will be trying to catch up, right? And that's going to be it's going to be a better balance, right? And that's what I'm after with SingularityNET and Hyperon and predictive coding, and why I think collaborating with Quai on various things can be helpful also, right? So I mean, it is up to us to sort of steward the emergence of AGI and ASI in a beneficial way, and the people in this room at least have a leg up on most people, because we get that open and decentralized at least are very, very valuable ingredients.
Thank you very much.
Wow, thanks so much.
I want to do one question. Wait.
One thing I forgot to say, so there's a bunch of developers in here. I would encourage people to go and just play around with our meta programming language. Like, it's open
Before
source,
you leave,
open source code, you can use it, and we could use more developers hacking on meta.
it's my pleasure to announce that Kristi Noem was fired an hour ago. If you haven't. Serious. She literally was fired 1 hour ago. So things are getting better while we're here. Do we have time for one question for him? Please. Anybody got a great question? Because that was a lot to. That's a good one.
The best place to find my papers would be a link that isn't that obvious. So if there's somewhere I can email, then everyone would get it. It would be great. I will do that, because there's a lot of information at SingularityNET.io about what I'm up to and the things I'm doing. And there's Hyperon.dev has links to all the code for Hyperon. But for my papers, I'll send you another link, actually.
Okay.
So
Thanks so much, Ben.
I've got a question.
No, I'm sorry. Yeah, you, sir?
Yeah. Me, sir. Yeah, my name's Riza Rasul. I'm asking for a friend. Gosh, you said you saw my presentation on fluidic neural networks. Yeah. I think we need to get a room, because this is this is like a pet project. I got my, we've got the director of research, Solomon Satari. He'll speak later on, but we're almost scared to talk about this stuff. I gave a presentation on my vision, my insight, I guess, into how neural networks and quantum mechanics look very similar. The neural network and the wave function look and behave in a very similar way. You've got at one end, you've got an input, which is an observable. You've got an output, which is an observable. And in the middle, in neural networks, they call it a hidden layers. In quantum mechanics, it's called a wave function.
Sure.
And in both cases, the high priests of both disciplines say, you're not allowed to ask what's inside. It's unknowable.
Yeah, well, the thing is, the thing that led me to fluid neural networks is the HJB equation, Hamilton-Jacobi-Bellman equation, which is a basic equation of optimal control, which underlies reinforcement learning. I mean, this equation describes the space of volume-preserving diffeomorphisms of a fluid evolving by Navier-Stokes equation. But the HJB equation, if you complexify it, also gives you the Schrodinger equation, right? So I mean, the quantum math and reinforcement learning math and fluid dynamic math they're the same thing under some one-to-one transformations.
We need to get a room.
Get a room.
So I mean, now how to cash that out in a scalable way in practice is an interesting question. And I implemented one prototype of a fluid neural network and then haven't done anything more with it because I've got so many other things to do. And you may be in a similar position, but it's a very important direction. Yeah.
Fantastic.
Okay.
Thank you for your question, Rico.
Thanks so much.
Thanks. Okay.